Hey guys, this is the second part to the factor theorem booklet. You have example 7, 8, and 9 to go. I'm going to do example 7 with you, and then you can do 8 and 9 on your own. Nothing crazy new in this video. It's just going to show you that we have a longer process now because we're factoring an x to the power of 4 polynomial. It's good practice in the sense that we're actually going to be doing the exact same thing twice as we go through. So in the booklet, you'll notice that if you're going through the notes at all, that it shows you the possible factors of this question. Just a reminder from the integral zero theorem that that comes from the constant. Okay, so in this case, that would be plus or minus 1. All these will be plus or minus 1, 2, 3, 6, 9, or 18. Those are all factors of 18. I'm not going to write those out, but they are in the notes, and that just tells you that you can check all of those numbers. I really hope that that doesn't happen as we go through. Okay, so I'm going to check first for the remainder theorem or the factor theorem here, f of 1. Okay, so I go 1 to the power 4, and I'll just write out all of that substitution. You can follow along with me as I go through that. Okay, that's going to end up equaling 1 minus 3 minus 7 plus 15 plus 18, and in that case you end up with negative 2, negative 9, 6 plus 18, aka not equal to 0. So I don't even care what that number is. We're going to go f of negative 1. Anytime 1 doesn't work, jump to negative 1. That's the common one after that. That should end up working, at least we hope. All right, so I plug in negative 1 to every spot of x. You'll notice that I think 18 is off the screen already. These are some pretty long questions. I'll do my best to stay on. All right, we got 1 minus 3 times negative 1 minus 7 times 1 minus 15 plus 18. You get plus 3 here, right? So you get 1 plus 3, which is 4, minus 7, negative 3, minus 15, negative 18, plus 18 is 0. There we go, negative 1 works. So I'm going to factor this out, or divide this out, sorry. We get 1, negative 3, negative 7, 15, and 18 from above, and let's do some synthetic division. We get 1 there, negative 1, add it to be negative 4, multiply, gets me 4, negative 3 when I add, positive 3 when I multiply, 18 there, negative 18 there, should end up with 0, which we do. Okay, so that means that so far our division is x plus 1. Remember, it's always the opposite sign in that portion. Now you're taking x to the power of 4 divided by x plus 1. So the newest degree is x3, right? It's always 1 less than what we started with, minus 4x squared minus 3x plus 18. Okay, that's what we have so far. Here's the problem. The fully factoring part, if you noticed from the last video, you would then go x plus 1 and then factor a crisscross here. I don't know about you guys, I can't crisscross x cubed. So here's the really unfortunate part. We now have to check again. Okay, so again, this might be off the screen, but that is, we're good. That is checking again. All right, so now in this point, to factor this down, we're basically back to the first video and doing this division now at this point in time. Now, there's a little bit of strategy here that is pretty common as we go through, and it's not always necessarily true, but because our factoring is already, or our factoring's already got x plus 1, it's pretty common that checking our new polynomial, let's call it p of x. Okay, so basically now we have this x cubed minus 4x squared minus 3x plus 18 from the bottom. Now that we check this one, I would not check 1 or negative 1. I wouldn't. 1 would not work anyway. We already checked that. Negative 1's there already. It's unlikely we get it twice. It does happen. Sometimes you get x plus 1 times x plus 1. What I would end up doing now at this point, because you've checked those, is I would end up going p of 2 and p of negative 2. All right, so if I do p of 2 from here only, I don't have to do this one now. I go 2 cubed minus 4 times 2 squared minus 3 times 2 plus 18, and that is 8 minus 4 times 4 minus 6 plus 18. So that's negative 8 minus 6 plus 18, which is negative 14 plus 18, which is 4, not equal to 0. So now let's do negative 2 negative 2 cubed minus 4 times negative 2 squared minus 3 times negative 2 plus 18, which I think is off the screen now, but you guys can write that out. Oh, still good. Negative 8 minus 4 times 4 plus 6 plus 18. Now in this case, I get negative 8 minus 16, which is negative 24, plus 6 is negative 18, plus 18 equals 0. Thank goodness that we don't have to check 3 and 6 and 9 and 18. P of negative 2 works. Okay? So what that means is, you can pause the video if you want to, because what I'm going to do is I would keep writing this below. I'm just running out of space on my whiteboard. So keep writing below here. I just need to erase it so I can show you guys what happens next. Okay? So right below here. Okay, so now that we know that P of negative 2 works, I'm going to take this here, okay, and I'm going to divide by negative 2. All right, and I've got 1, negative 4, negative 3, and 18. 1 there, negative 2 there, negative 6, 12, 9, negative 18, 0. Okay, now my final factored form is still from the original here. So I'm going to go x plus 1 from the first part. Okay, that doesn't go away. That stays with it. X plus 2 from the new part. And x squared minus 6x plus 9 also from the new part. Last step to fully factor. This can now crisscross. I get x plus 1, x plus 2, and in this case, it's actually x minus 3 times x minus 3 when you crisscross, which looks like this. Okay, make sure you get that to that fully factored part for full marks. Okay, so just a review. Remainder theorem at the start, you're going to get an x cubed. You do remainder theorem again. You do synthetic division again. Make sure you keep the original binomial from the first part, and then do what we did in the first video a couple days ago, where you get this part, crisscross down, and now we have our final answer. One thing to note in terms of degree of our original question, the degree was 4, and the max number of x-intercepts would then be equal to 4. But if you look at our question, just to jump ahead a little bit to the next video for next week, we got negative 1, negative 2, and 3. In this case, the x-intercepts we have are 3. Okay, that's the max number of x-intercepts we could have. We're going to end up with 3 x-intercepts for the 3 brackets that we ended up with. That's looking ahead, not something you need to know right now. As long as you get to this final answer, you're good to go.